right. Okay. All right, welcome back to track 2 of Security B-Side San Francisco. Thank you for coming upstairs. Here we have Jesse Endahl presenting Securing Kubernetes. Kubernetes? Something like that? By the way, we have a new prize. If you ask an excellent question, Jesse will give you one of these boards for the electronic badge so you can build your own. So think about your question in advance for that. And with that, here's Jesse.
Hi, everyone. As you may have guessed, we're talking about securing Kubernetes today. My name is Jesse Endahl. I'm the CSO and CPO at Fleetsmith. We're a cloud-based SaaS product that does Mac fleet management, so secure management of apps, settings, et cetera, for your Mac fleets. Previously, I was at Dropbox, working with a few of the folks that are here today, as an infrastructure security engineer. All right, and I realized I just started early there. Okay, so let's jump in. So what is this talk not about? I wanted to start with this because there's a lot of things that I could talk about that I won't talk about because there's just not enough time. So let's go through that real quick. First of all, setting up Kubernetes itself. Won't be talking about that. That's a whole different talk. In fact, it's a whole book, and this is really great. It's in pre-release right now on Safari Books. I highly recommend it, by Kelsey Hightower. Second off, setting up Vault itself. That's the secrets management tool from HashiCorp. Really great. A lot of tricky things here if you're setting it up, not just for secrets management, but also if you want to use it as your PKI, as we do. There's some tricky stuff there, like how do you make sure you design your CAs in a safe manner. You've got the chicken and the egg problem of how do you bootstrap, how do you get certs from a PKI to protect your PKI when it's not up and running yet. That's an interesting dance. And then the third thing is getting cut off here. Yeah, this is a really tricky one. Bootstrapping Vault tokens safely into your VMs and containers. Very tricky as well. All right, secrets management. Won't be talking about that either. The thing I will say is don't use Kubernetes secrets. They're not secret. They're just base64. Not great. Definitely check out Kelsey Hightower's proof of concept on using Vault with init containers as a cool way of doing that without any modification of Kubernetes itself. And then there's some really great discussion. That's a huge, many response long thread on a GitHub issue with discussion about how to improve Kubernetes secrets in the future. Container hardening. If you're interested in this, definitely check out the NCC papers by Aaron Gradafiore and Jesse Hertz. Really great stuff. Aaron's paper has been called the War and Peace of Container Security. I think it's around 200 pages long. It goes through like the whole history of containerization and VMs and hypervisors. It's crazy. Jess Frizzell's work on default seccomp profile for Docker was really cool. Eliminates, I think, around 50 syscalls out of the box. Unfortunately, Kubernetes disables that for you, helpfully. So if you want to turn that back on, check out that GitHub issue. It's really easy to turn that back on using something called security contexts in Kubernetes. Also, yeah, I just mentioned this, but security contexts let you do more things than just specify a seccomp profile. You can also specify UID, JID, GID capabilities, SE Linux roles, etc. So pretty cool stuff. Check that out. Alerting and detection, won't be talking about that either. There's a cool project from CoreOS called Claire. This does scanning of your container images for vulnerabilities in packages. It's pretty cool. And then Go Audit, not really directly related to container security, but if you do need to do, if you want Audit D on all of your hosts where you're running your containers, really great stuff. All right, what this talk is about is securing Kubernetes itself. What is Kubernetes? Some of you may be asking yourselves this question. You may have heard Kubernetes is really cool. It does container orchestration. What does that mean? Well, this is the official description from the homepage. Kubernetes is an open source platform for automating deployment, scaling, and operations of application containers across clusters of hosts, providing container-centric infrastructure. Okay, what does that actually mean? Basically, it's a tool that lets you deploy all your microservices that make up your application without going totally crazy. So there's a bunch of glue that you need to actually be able to do this, and Kubernetes is the glue. It figures out which machines containers should be placed on, how many should exist, handles things like scheduling, load balancing, etc. Also does data volume sharing. So if you need to share data between containers, helps you do that. If you need to share data from a host to a container or vice versa, helps you do that as well. Also figures out if it's actually safe to send data to a container. Is it actually healthy? Is it up and running? Can it take traffic yet? Handles all of those things for you as well. And finally, it really makes deployments a lot easier. So if you have 30 microservices and they're all versioned differently, and basically you want to do a release, right? Maybe you do that every day, several times a day, every few minutes, once a month, who knows, doesn't matter. But every time you do a release, you want to know that everything's up and running. If it's not healthy, Kubernetes can actually help you stop that deployment automatically and roll back to a previous deployment of your containers using a feature called deployment. So it also helps a lot with just the deployment process in general. So these are some keywords you're going to have to know throughout this talk. I may have already said a few of them. A node is just Kubernetes term for a host. This is probably a VM if you're in the cloud. A pod is a group of one or more containers. And a service is an abstraction that lets you say, here's the service. Let's say it's your Nginx at your edge. What happens if those containers die and come back? You still want to be able to route traffic to those new ones, to those new pod that comes up, right? So this is just an abstraction that lets you say, always let me address this thing at this address. All right, there's two types of Kubernetes hosts. There's the master and the worker. Outside of that is etcd. This is where all of the cluster state is stored. It's a distributed key value store. So you've just got etcd running on a bunch of VMs. And we'll get into where that fits into the picture in a second. Master components. There are three main components to the master. The controller manager, the API server, and the scheduler. The API server is the real big boss. That's where most of the magic happens. Totally stateless. It's just a REST API that everything else talks to. The controller manager enforces the state of the cluster. So you describe the state you want things to be in. The cluster manager talks to the API server, makes that happen, and makes sure it stays consistent for you. You've got the scheduler. This is purely responsible for scheduling those pods, those sets of containers, across all your hosts. That's it for the master. Then you've got the worker. The worker has three components as well, arguably only two. Up to you whether you consider your container engine as part of Kubernetes or not. Obviously, it's pretty critical. That's your Docker or Rocket or whatever you're using to run your containers. Technically not part of Kubernetes itself, but it does run on the worker hosts. Kubelet, that's the main, the big boss for the actual running of the containers, the pods themselves. That's the main agent that's talking back to the API on the master. You've got the proxy. This is responsible for directing the traffic for different services to the right location. This is also talking back to the API server. So what does this look like when you put it all together? It looks like this. Stunningly, this does not exist online anywhere that I could find. Not with the actual service names. There's abstractions on all the other charts that I could find. So this is how it actually works. And then, of course, there's actually a connection here as well between the container engine and the kubelet. As you can see, when you start thinking about security here, you see the obvious root of trust is etcd for the cluster. That's where all the state is stored. So if something can talk directly to etcd, that's bad news. Same thing where if everything could just do any arbitrary API command, that would also be bad. All right, I always find it helpful before actually trying to secure something with TLS to actually look at where everything is listening. This was also really hard to find a complete list, so I created one. Start with etcd. This is listening on two ports, one for client operations and one for server operations. So client meaning Kubernetes API itself is going to be the client in this situation, talking to etcd on port 2379. etcd itself, when it's replicating all that data from one host to another, is using its peering port, which is 2380. Quick note on the master before we go on to the next slide. There's a bunch of ports that only listen on loopback, and that's for the other master components, the scheduler and the controller, to talk to the API. But since those aren't going over the network, Kubernetes, at least in its current version, Just makes those listen on loopback. There's no security. Well, if you have someone root on that box, you have bigger problems. And then you've got the public ports, and those are the ones that I'll be talking about here. So here's where it's publicly listening, accessible on the network. The main API port, I'm putting what you should have there for the API server. I believe the default is actually 443, and I'll explain later on why you probably want to change that to 6443 or something else. The scheduler, it's got a health check port, and the controller has a health check as well. All right, the worker ports. The kubelet, which is, again, the main kind of master process, if you will, on your workers, also has an API, and that's on 102.50 there. And then you've got a read-only port, which you can disable if you don't need it. The cAdvisor port, which you should probably disable if you don't need it. It's just statistics and information, but it's kind of unnecessary. And then the kube proxy, you won't see anything in that port range unless you've created a Kubernetes service, and that's what I talked about earlier, when you need a consistent way of addressing your pods. All right. So that's an overview of kind of all the different components, where things are listening. Let's go ahead and move on into the authentication and authorization here. So there's sort of 3 stages to the flow here. The ones you probably are going to care most about and that I'll focus the most on today are the authentication and authorization stages. But the admission controller stuff is pretty interesting as well, and you'd want to watch out for that, and I'll mention why at the end. All right, authentication. So there's 2 main types of accounts. There's user accounts and service accounts. There's a pretty big difference between them. The biggest is that service accounts are stored inside Kubernetes itself in etcd, in part of the cluster state. You can create those accounts from the command line using the kubecontrol command line tool. You cannot do that for user accounts. Those have to be specified in YAML. That's probably the biggest difference. For user accounts, you've got a few different options for authentication. This is not an exhaustive list of everything they support, but these are probably the ones that are going to be used most frequently. The one I didn't include that I probably should have, they do support OpenID. So if you wanted to, you can have your users authenticate with their Google, their G Suite credential to Kubernetes if you wanted to. The one we're going to be interested in is the client certs. Service accounts can't use anything but JSON Web Tokens directly. The way they secure this, if you do have a CA and you want to secure everything with TLS, is you actually configure Kubernetes to sign these tokens with a private key, so that once they actually reach the API server, can validate that it was signed by the same CA. All right, authorization. So there's 2 main options here. There's other options, but you probably don't want them. It's like deny all or like allow all. The ones you actually want to use are probably just one of these 2. So ABAC is the current implementation, the current default, and they're moving to RBAC, I think, in the next release, 1.6, which is coming out, I think, in March. And the admission controller, I promised I would mention this briefly. That's what actually happens after authentication and authorization have already completed. There's this check that gets done to see, is there any special magic that needs to happen here before we actually write this to etcd. And this is where things can potentially get dangerous. I'll mention why in a bit. This is what the config looks like for ABAC, the current authorization implementation default in Kubernetes. This is an example of the role-based access control that they're moving to. Quick check-in of what we've covered so far. We've gone over the Kubernetes components, where they're listening. We've gone over the chain of trust, etcd to the API server to the kubelet, as well as how authentication and authorization work in Kubernetes. So this is all very academic and interesting, but what's the actual threat model that we're trying to protect against here? For me, this is the most interesting. Might be different for you, but for me, okay, they've escaped the container. They've got a shell on a worker VM. What can they do from that worker? Obviously, you don't want them to be able to connect directly to etcd and modify any of your cluster state. You don't want them to be able to man-in-the-middle traffic to and from any of those other Kubernetes components. And so those are some of the things that we can protect against using TLS. So TLS certs can be used to kind of solve all these problems for us. You can use them for authentication. They can assist with authorization by, if you embed the group name, if you're using RBAC, into the cert, then during the authorization stage, it'll actually look into that, introspect into the cert and pull out the group name and then apply those correct permissions. So that's pretty cool. And of course, transport encryption. So how do we actually configure Kubernetes for TLS? I'm going to walk through this pretty quick. I just included these mainly so that they'll be in the slides later on. You can look through them. So obviously you need to specify etcd's config, probably the most important for the aforementioned reasons. Keep in mind that you're going to want to specify both the key pair for client, etcd in client mode, and in server mode, right? This is the main API server for Kubernetes. Pretty clear cut here. These are not full config files. I just pulled out the TLS related stuff. So you've got your kubelet user there, you've got your scheduler. In an ideal world, these obviously have separate certs and keys, right? I wanted to go through this step by step because there's so many different TLS config options in this file. It's kind of hard to see what's going on. So the first part is when the API server is acting as a server, we need to accept incoming connections from the kubelet that's running on those workers. So that's that config there. We've got it the other direction. So the API server as a client connecting to the kubelet on the workers. You've got acting as the API server acting as a client to etcd here at the top. And then I mentioned earlier, if you want to actually secure those service account tokens, those JSON web tokens, you have to sign them to make sure that the API server actually knows that they are from the same CA. And finally, unless you need this for some reason, you should probably just disable the anonymous authentication. So this is like nothing required. There is some amount of information you can get from that. Why expose it if you don't need it? Scheduler config. This kind of just pulls in all the same config that was specified in the earlier kube config file. This is that file actually, the kube config. And the kubelet. This is again the part running on the host, right? Or sorry, on the workers. And the proxy also pulling in that same kube config here. Okay, great. So that's all fine and dandy. We know how to configure it now. But where do we actually get these certificates from? So we get it from the Vault PKI. And once you've done all the painful work of setting up vaults and setting up the Vault PKI, which, as I mentioned, is a whole separate talk, then it's as easy as this. You just do a simple curl, include your Vault token there, and then you specify, what you want the CN to be, the common name. So in this example, we're grabbing one for the kubelet, and we're just catting this to a temp file, doing a little parsing, and then removing that temp file. I forgot to mention one thing that's relevant to this bit here, which is that you have several options for volumes within Kubernetes. So you can store this on a memory-only volume. So this actually isn't written to disk. It's just stored on a RAM disk, essentially, which is nice. So what have we accomplished at this point? We've secured etcd, the API server, the scheduler, the controller, and the kubelet, all with TLS, which is wonderful. There are some limitations in Kubernetes itself right now that are a bit disappointing. There are workarounds, which I'll show on the next 2 slides. But the biggest one is that we haven't secured the connections from the API server to the nodes, pods, and services. And unfortunately, this is not possible to do with TLS with Kubernetes currently. I assume that it will be possible at some point, but I haven't seen any indication of when that would be. And that's mentioned on that page, if you're curious where I got that. Another huge limitation, and this one's easier to work around, but there's no support for specifying an OCSP server or a CRL file in Kubernetes at the moment. Kind of subpar. Solutions. So for the first issue that I mentioned, one solution is securing all this stuff with SSH tunnels. I'm not thrilled about that, but it is one option, and this is actually what Google Container Engine does to protect you from this. They do a bunch of stuff to secure Kubernetes way more than you would otherwise get out of the box. Out of the box, you don't get anything. It's all plain text. So that is a good reason to use Container Engine if you don't want to go through all the hassle on this stuff. One solution to the no revocation problem is obviously just doing short-lived certs with aggressive rotation. So that's probably the best bet right now, and maybe that's a better way to go anyway. The other option is instead of doing this at the authentication stage, you can wait until authorization, essentially, and just kill that user account. Don't just remove that user account from your configs. Unfortunately, I believe this does require restarting the API server, which kind of sucks because now you have to schedule time to remove accounts. I hope they fix that. Additional work that you want to do that I didn't really cover, but I'll briefly cover it here. If you want a secure Kubernetes deployment, you probably also want to secure the communication between Kubernetes and the container engine, for example, Docker with TLS as well. You would want to give every user and service account a separate certificate. Make sure you configure proper permissions for each of them, preferably using RBAC, like I mentioned, coming out very soon. I think it's in beta currently, or it's in alpha now and it's moving to beta, I think, in 1.6. And yes, the admission controller. So I mentioned I would come back to this. This is pretty important. By default, the admission controller for service accounts gives every pod access to what's called the default service account role. And so that means that all of your pods are just using one universal account to talk to the API server. Obviously, that's really not great. You can turn that off, and then you can issue individual tokens, per role or per group of containers that you per pod that you have, which obviously would be a lot better than one for everything. Additional things you should probably do is disable that cAdvisor listening port unless you need it. I mentioned that earlier. Disable that read-only anonymous access if you don't need it. And yes, the reason you want to do this is if you are running Kubernetes in production, as we are, you probably don't want people to be able to run kube control commands from outside of your production environment. And obviously, if it's listening on 443, unless you work somewhere where you don't need to allow 443 incoming to production, which I've never heard of a place with that type of setup, you probably will want to switch the listening port for Kubernetes so that people can't just run these commands from their laptops, totally bypassing your SSH bastion. So 6443, it's a decent choice for that. Also, yeah, that amazing default seccomp profile that Jess Wiesel created while she was at Docker, that's totally disabled by Kubernetes. You probably want to turn that back on. It was tested very extensively at Docker, so it shouldn't interfere with anything. And it's just, you basically get it for free. It's really easy to turn that back on, just a 2-line change in your YAML file for the pod. And the config to do that is on that GitHub issue. All right, so here's a recap of everything we've talked about. We went over what Kubernetes is, all of its components, the network connections between the components, our threat model for this talk, the critical connections between those components and how to secure them with TLS, example configs, limitations and workarounds with Kubernetes in terms of security, and then finally the additional work that you should probably do after you've implemented TLS. You've got that laundry list of other fun tasks to take care of if you want a secure Kubernetes deployment. And I think that's it. I have 2 more slides after this with a list of a bunch of links that I used to put together this talk. So those will be in the slides as well. That's it. Yes?
So the CTF was running on GKE and they didn't disable the default service account.
Yeah.
Can you illustrate why you would want pods to have access to API server at all?
Yeah, the question was, he mentioned that Kubernetes was being used for the CTF here, and the default service account wasn't disabled. And the question was, why would you actually want a single universal default service account? I think that the answer to that question is you don't. And the reason they did that was, I think, just sort of for speed during development. I don't think it was a conscious, like, we're going to do this after having thought through all the security implications of it. In fact, there's a big discussion on this on a GitHub issue, and basically everyone agrees, like, yeah, that was bad. We shouldn't have done it that way. They're fixing that, I believe, in 1.6. They're moving the service account to RBAC and presumably scoping down the permissions that the default account gets. I don't know if they're actually disabling that automatic issuing of, like, the same account for all services, but at least it is going to be scoped a lot better than it is now. Question?
So you said don't use etcd secrets because of this basic support. What would you use? Let's say we want to protect the IDRSA, because you also suggested protect connections by SSH.
Yeah.
So how are we going to protect the connections by SSH if we can't protect the private key for the SSH connection in etcd securely if we can only do basic?
Yeah, so the question was, if you are not going to use etcd for secrets, what should you use? Because you obviously need to put secrets somewhere. I do want to clarify one thing there, which is that specifically the thing you don't want to use is Kubernetes secrets, and Kubernetes stores the secrets in etcd, yes, but the issue, at least for the purposes of this talk, the issue isn't that etcd itself isn't storing those secrets encrypted on disk. That's a whole separate issue. But the issue is just the kind of scoping of the role that's used to access it, the tokens, as well as, I mean, it would be great if they were stored encrypted, obviously. And so, sorry, to answer your actual question here, what do you do today? So what you do today is just use something else for secret storage. So we use Vault as a general secrets management tool as well as a PKI. And that's definitely what I would recommend. The thing I mentioned earlier about proof of concept from Kelsey Hightower, using init containers to basically interact with Vault and get secrets from Vault. That's what I would look at there. Yeah, that gets to the chicken and the egg problem of how do you secure Vault itself. Which I'm happy to talk to anyone afterwards. It's kind of a long discussion, but it is possible to do. It's just a little dance you have to do. You're welcome.
You mentioned that SecCom profiles were disabled by default.
Yes.
Is there like a compatibility issue in the past? Like what led to that? It seems like an odd decision.
Yeah, so the question was basically why was the default Docker SecCom profile disabled by Kubernetes? As far as I can tell, there wasn't a great reason for that. I think there was some general fear that maybe it would interfere with, with people's containers. But I think that fear was maybe unjustified because there was a lot of testing that was done to make sure that that profile wouldn't interfere with. I think they tested a whole bunch of Docker containers and got to the point where nothing that any normal microservice would need was being blocked. So yeah, there is actually another GitHub issue now to turn it back on. But I don't think there was a great reason for turning it off other than kind of fear. Yep.
Is there a plan to make Kubernetes GUI-based? Make it GUI-based?
Oh, is there a plan to make Kubernetes GUI-based? There is actually a GUI now. I think they introduced it in 1.4. I don't think you can do everything from the GUI yet, but that's definitely there. Then you get into the whole, how do you, now you have to control access to that as well. So I guess you could probably have both. By the way, you can have more than one authentication type enabled at once. So you could use client certs for people who are, within production. Yeah, you could use clients, but then or client certs within prod, but then you could use OpenID for maybe the web UI portion. Yeah, exactly. Yep. Are there other PKIs that you could use other than Vault? There are. I would look at Acme CA, so that's the one that's used by Let's Encrypt, And the core TLS operations in that are handled by CFSSL, Cloudflare SSL. And that, because it was being used for Let's Encrypt, they actually NCC Crypto Services actually audited all of that code. So it's probably pretty good. So that's another one. If you do want to be brave, you could you could use CFSSL kind of as a library and sort of build your own CA on top of that, just like Acme did. That would be a good starting point. That's obviously going to require a lot more engineering hours, but yeah. Cool. Looks like that's all we have time for. Come find me if you have more questions. Thank you.
All right. Thank you very much, Jesse. Before you leave, a Fitbit for you from our sponsor. Thanks very much.
Thank you very much.
All right. Coming up next, we have Amanda Rousseau in about 10 minutes. So, Amanda, is she in the house yet? No. All right. 10-minute break. Come on back. A reminder, there's a happy hour tonight, 5:20, sponsored by Salesforce.